Hi guys, welcome all to the Max lecture series. So in this series we are learning how to calculate the maxima, minima and its correspondent value, and what is called point of inflection, what is the difference between point of inflection, maxima, minima, everything we understood. And we also saw how to identify the maxima, minima when two independent variable is given in a function, and we also saw how to identify the maxima, minima when only one independent variable is given it in a function. Now let us see one more question in this session. Before looking into the solution, I have requesting this many times. If you are really understanding the content whatever that I am delivering here, don't forget to click that like button and also share it with all your friends. Let us see the solution for the given question. What is the question given here? If you observe the question deeply, the function f of x comma y equal to 2x power 2 plus 2xy minus y power 3. That is the given question. Whereas this function has, see, it's one of the beautiful question. They haven't asked any maxima, minima or point of inflection, nothing. Just we have to identify the stationary points. How will you identify the stationary points? First of all, it is very easy. Usually, so far whatever the problems that we have been solved, how will you calculate the value of maxima and minima? We have to take first order differentiation for this function, and then we have to equate it to 0 in order to obtain the stationary point. Then again from the stationary point, by substituting those stationary points values in the second order derivative, we can check where maxima will exist, where minima will exist, where point of inflection will exist, is it possible or not, everything we used to do. So in order to identify the stationary point, the one and only thing that is required is just to differentiate the function with respect to x. If only one independent variable is given, we have to differentiate only with respect to x. If two independent variable is given, then separately differentiate. First differentiate the function with respect to x, then differentiate the function with respect to y, then equate them to 0, identify the values of x and y. That's all. That set is called stationary points. Yes or no? Yes sir. Now if you take the given function, of course there are two independent variables given in our question. See there, x and y. It means our given function is depending on two independent variable x and y. So take the function, differentiate once first with respect to, so I am going to use dou. What I told you, we have to use dou when we are having more than one independent variable in a function. So differentiate the same function with respect to y separately, differentiate the same function with respect to x separately. So if I am differentiating the function with respect to y, what you will be getting, sorry, with respect to x, what you will be getting, 2x square plus 2xy minus y cube. That will give you, 2x square will give you 4x minus, sorry, not minus, plus 2xy will give us plus 2y. I am just doing differentiation with respect to x. So plus 2y. If I will differentiate y cube, that will become what? It will be 0 sir. So that will be 0. After that, again we have to differentiate the same function with respect to y. When I am doing differentiation with respect to y, what will happen? 2x square will become 0 plus 2xy will give you 2x minus y cube will give us 3y square. That's all. After finding the first order differentiation, our next is task. See, sometimes in your examination people also represent it like this, fx, fy. It means that function has been differentiated with respect to x once, and this function has been differentiated with respect to y once. After that, what we have to do, just to equate the resultant value to 0 in order to identify the stationary point. So let us looking into the solution for this question. See, from the first equation we got 4x plus 2y equal to 0. From this we can say 4x equal to minus 2y, or we can say the value of y is equal to minus 2x. Am I right? See there, 2 times of 2 will be 4. And if I am passing this minus to the left hand side, it will become y is equal to minus 2x. Yes, we got one relation between x and y. Let us take the second equation. From the second equation, what we observed is 2x power 2, am I right? 2x minus 3y square, sorry, that is 2x minus 3y power 2 equal to 0. Yes sir. And one more thing, what we know, y can be replaced by minus 2x. Just now we saw the relation. If I will substitute it here, then this will give you 2x minus 3 into y can be replaced by minus 2x whole power 2 equal to 0. From this further, we can write 2x minus into minus, see, sorry, it is minus 3 only, minus 2x whole square will give you 4 into x power 2 equal to 0. Further, 3 times of 4 will give you 12. So, 2x minus 12x power 2 equal to 0. Yes sir. From this further, how can we write this expression? We can take 2x from this outside, then it will become 1 minus 6x equal to 0. From this, if I will equate these two variables to 0, then it will give you x equal to 0. This one will give you x equal to 0. If I will equate this one to equal to 0, this will become x equal to 1 upon 6. Yes, successfully we have been identified 2 points y and 2 points x. X had given 2 points. Now we have to identify its correspondent points for y. Go back to the equation. Now if you observe, already we saw the relation y is equal to minus 2x. If I will substitute these values into that in order to obtain the y variables, let us see what will happen. When I am replacing x equal to 0, obviously y also will become 0. When I am replacing x equal to 1 upon 6, then the value of y will become minus 2 into 1 upon 6. This will be equal to minus 1 by 3. So what is the stationary points? When x equal to 0, y also 0. When x equal to 1 by 6, y will become minus 1 by 3. So 0, 0, 1 by 6, minus 1 by 3 are the stationary points. Is there any option like that? See, let us see. They have told that only one stationary point at 0, 0. No, that is wrong. Two stationary points 0, 0 and 1 by 6, minus 1 by 3. Of course, that is correct. Obviously, other two options are going to be wrong only. So this is how we are identifying the points. Now, can you please do me a favor? We know how to identify the local maxima and local minima when two independent variables are given. Can you please do it? Here we have identified the stationary points, right? Yes sir. So stationary points we identified. We know both x, y we know. By utilizing this, identify dou square f by dou x square, dou square f by dou y square, dou square f by dou x, dou y. Then check, further how to check the local maxima and local minima. Okay, just to proceed further, find out the answer, drop your answer in the comment section. This is all for this lecture. Remaining things we will see in the next class. Thank you all.